Again, welcome back to Calculus Mathematics 200. In this lectures, we're going to discuss the concept of functions and also their graphs. So our main objective is to use the function notation to represent and also evaluate a function. Also, we are going to learn how to find the domain and also the range of a function. So a relation between two sets, this is uppercase X and Y. So we have two sets, uppercase X and Y. It's a set of order pairs, each of which the form lowercase x and y. And x, lowercase x will be the member of the uppercase x set, and also lowercase y is the member of the uppercase y set. So a function from x to y is a relation between x and y that has a property that any two order pairs with the same x value should give us the same y value. In this case, our x will be the independent variable and our y will be the dependent variable because, again, x determines the value of y. Now, here we have the definition of a real value function of a real variable. Now, let's say we have x and y is a set of real numbers, and the real value functions f of a real variable lowercase x from the set x to y will be the correspondence that assign to each number x, and that's lowercase x in the uppercase x, which will be the set, exactly one number y in also uppercase y. So the domain of f is the set x values, and also y will be the range. So here we say the number y is the image of x under f and is denoted by f at x, which is called the value of f at x. And the range of f is the subset of y, and it consists of all the images of the numbers in x. So here, in short, to summarize everything, the x values, in this case, the x lowercase, in our set uppercase x will be called the domain. And then the range will be the y values in our uppercase y set. And always the x may determine the y value. So let's see an example. Here we say functions can be classified in different ways. However, you will concentrate primarily on functions that are given by equation involving the dependent and also dependent variable. So for instance, here we have x squared plus 2y equal to 1. Our x will be our dependent variable and y will be the dependent variable. So we can define y, the dependent variable, as a function of x, the independent variable. So in this case, y will give us 1 minus x squared divided by 2. So that's what we have here. So to evaluate this function, that is to find the y value correspond to the given x value, we get y equal to half times 1 minus x squared. Now, using the function as using the f as the name of the function, we can write this as f at x equal to half times 1 minus x squared. So this means any value of x may determine the value of f at x or y. So the original equation, x squared plus 2y equal to 1, implicitly define y as a function of x. So when you solve this equation for y, you are writing the equation in explicit form in this case. So let's see an example. Here they say we should find the function f, which is defined by f at x equal to x squared plus 7. If we know this function, f at x equal to x squared plus 7, we can be able to find a, f at 3a. So f at 3a means we are going to substitute 3a into x squared, and we solve it. Same thing, we have f at b minus 1. The same thing, anywhere we see x, substitute, and the same. So let's see the first one. So the first one, to find f at 3a, to give us x squared plus 7, and x is 3a. So we get 3a squared plus 7. So when we solve this, we are going to get 9a squared plus 7. Now let's look at b. b, we have f at b minus 1. Okay, so this means x equal to b minus 1. So we get b minus 1 squared plus 7. And this will open the parentheses. We get b squared minus 2b plus 1 plus 7, which will give us b squared minus 2b plus 8. Now let's look at the c. In the c, we have f at x plus dx minus f at x over dx. So we have to be careful here. We have a lot of x values. So our first equation, s squared. So we have s plus ds squared plus 7. The second, we have only x. So it will be s squared plus 7 divided by ds. Now, dx is not a function. So you can see here we have f at x plus ds. So it's a function. That's why we substitute the function s squared plus 7. Same thing f at x, the same thing. But this ds is just a value or a variable. It's not a function. So from here, we can solve this equation. We open the parentheses here, so we get s squared plus 2s dx plus ds squared. This is perfect square formula, plus 7. And here we have minus s squared, minus times positive also give us minus 7. So we have minus s squared, minus 7. Now let's see if we can cancel something or combine. Okay, s squared will cancel minus s squared. 2s dx didn't cancel, so we put it back. Also plus 7, cancel minus 7. And the x squared didn't cancel, so we bring it here, divided by dx. Now, if you like, we can take ds out, and then we cancel. So that's what we did. ds is common here, so we have 2s plus ds, all divided by ds. So we cancel the dx, and we get our final solution will be 2s plus ds, only if ds not equal to 0. Why? Because ds is denominator here. So next, let's discuss about the domain and the range of a function. We already explained the definition in the place. So again, the domain will be the possible x values, and the range will be the possible y values. But sometimes we have to be careful because, for example, here we are dealing with only real numbers. So a real number for, let's say we have a real number, a negative 10 square root, there's no solution. A square root always have to be 0 or positive values, from 0 to positive value. Also, we know denominator cannot be 0. Otherwise, the equation will be undefined. So when we are looking for the range domain, those are the two most important rules. Square root of a negative value or dividing a value by 0. So we can see the example here, f at s equal to 1 over x squared minus 4. You see what they told us here? X should be less than or equal to 5 or greater than or equal to 0. So if x is, let's say, 1 square, and we get the solution. So again, we will see more examples. So let's move forward. So let's do, on the other hand here, the function g at s equal to 1 over x squared has implied domain that will give us this. So actually, let's go back to the example. What I'm trying to say here is that, as we said earlier, there's two rules when we are dealing with the domain and range values. We don't want to divide the value by 0, and we don't want to find the square root of a negative value. So that's why here they are trying to tell us that if we get 4 here, 4 minus 4 will be what? 0. So that will make the equation, the function, undefined. So here we can even write it in a very nice way, which is what they did here. X can be, the domain can be any value, except it cannot be positive or negative 2. If it's negative 2 square will give me 4. 4 minus 4 is 0. If it's positive 2 square will give me 4. 4 minus 4 is 0. 1 over 0 is undefined, no solution. So I think this is the best way to put it. So here we can say that the domain of this function can be any value x, can be any value from negative infinity to positive infinity, but it cannot be negative or positive 2. Now let's see a nice example here. We have f at s equal to square root of s minus 1. So this is where we talk about that. So you can see the domain of the function here. We say can be any value. We always want s minus 1 to be at least equal to 0 or greater than 0. As we said earlier, if we have a negative square root, there's no solution. So that's why here we say the answer can be 1 to positive infinity. So which means if I have 1 minus 1 is 0. Square root of 0 is 0. 2 minus 1, 3 minus 1, all are positive values. So that will be the domain from 1 to positive infinity. Now, if I have, let's say, 0, 0 minus 1 is negative, square root of negative 1, there's no solution. So let's look at another example. So the range is the interval. So the same question, basically they are telling there's the range from 0 to positive infinity. So the graph will look something like this. It cannot be on the negative section. Now let's look at another example here. We have g at s equal to 4 minus s squared. Here also we have to be careful. We have a square root. We don't want a negative value. So here we say that 4 minus s squared should be greater than or equal to 0. Or in short, we can say s squared should be less than or equal to 4. Because if s squared is 16, 4 minus 16 will give us minus 12. We don't want minus 5. So that's why the domain here will be somewhere between negative 2 to positive 2. We don't want a value greater than 4 here. If s squared is greater than 4, then we are going to get a negative answer. So that's again to find the domain of a function. So here we say a function from x to y is 1 to 1, which means 1 to each y value in the range correspond to only exactly one x value. So if x is 1, I get only one answer. I don't get two answers. If x is 10, y is 300, not 300 positive and 300 negative or any other value. So a function from s to y is onto when its range consists of all of the y. And this will be the conclusion of these lectures. Again, hope to see you in the next lectures, and thank you for your time.